Welcome to this explainer. Today we are tackling a mind-bending thought experiment that is absolutely going to change how you feel about standing still. Right now, as you sit there watching this, you probably feel like you're completely stationary, right? But the reality is, stillness is just an illusion. Today, we're going to shatter that illusion by asking a simple but literally world-ending question. What if the Earth suddenly stopped spinning for exactly 5 seconds? Okay, let's dive right into this. I want you to look at this massive number. 1,670 kilometers per hour, or roughly 1,040 miles per hour. That is the incredible, breakneck speed you are currently hurtling eastward right this very second if you happen to be anywhere near the equator. Just to put that into perspective for a second, that's faster than the speed of sound. You are basically riding on a giant rocky spaceship spinning through the void. So you might be wondering, why don't I feel like I'm breaking the sound barrier? Well, the crucial point is that you don't feel this velocity because absolutely everything around you shares it. The ground beneath your feet, the buildings, the oceans, even the atmosphere itself. It's all rotating together at that exact same speed in perfect harmony. You really only feel motion when your speed changes, kind of like when you suddenly hit the brakes in a car. But what happens if that planetary motion abruptly halts? Well, to answer that, we first need to establish our baseline and understand the invisible forces at play before we break them. Section 1, the invisible spin. Right, so this basic law of physics brilliantly illustrates why we have to be super careful with our definitions today. Inertia is the tendency of objects in motion to stay in motion unless acted upon by an outside force. So if the Earth stops, what exactly counts as the Earth? Is it just the bedrock? What about the water, the air? Because of inertia, we're going to run 3 escalating scenarios to test what stopping the Earth actually means for momentum and, well, our survival. Let's move to our first scenario and see how this builds. Scenario 1, magic pause. This is basically the quiet version where magic freezes every single atom on the planet simultaneously. Now, what's really interesting here is that it completely debunks that famous myth that you'd instantly fly off into outer space. As you can see in our rules, gravity doesn't just switch off. Earth's rotational speed is way below escape velocity. So if everything stops at the exact same instant, there are no supersonic winds. The sun just appears frozen in the sky for 5 seconds, and geostationary satellites up in orbit would just drift a few kilometers east. In fact, if this magic pause happened, you would experience something pretty weird with your weight. Because the outward centrifugal force of Earth's spin suddenly vanishes, gravity would pull you just a tiny bit closer to the planet's center. You'd actually feel a little heavier, about 1/3 of 1% to be exact. So a 70-kilogram person would temporarily gain roughly 1/4 of a kilogram. But honestly, in 5 seconds, it would be over, and most of the world wouldn't even realize what just happened. Okay, now we remove the magic and look at the inertia nightmare. Scenario 2, the nightmare. What happens if only the solid planet, like the bedrock and the crust, stops, but nothing else does? Yeah, this is where things get completely catastrophic. If only the bedrock drops to 0 speed instantly, inertia completely takes over. The atmosphere, the oceans, cars, buildings, humans, we're not perfectly bolted to the Earth's core, right? To anyone on the ground, the air and water around you suddenly become a supersonic weapon, hurtling eastward at up to 1,000 miles per hour. Let's actually track this terrifying 5-second countdown step by step. Just 1 single second in, a 1,000 mile per hour wind scours the landscape. That's hitting with 25 times the force of the strongest hurricane ever recorded. It instantly obliterates anything not firmly anchored deep into bedrock. By 3 seconds, global power grids and communication towers completely fail as shockwaves tear across the continents. By the 5-second mark, any freely moving objects at the equator would have been thrown 2.3 kilometers, almost 1.5 miles eastward. I absolutely love how astrophysicist Neil deGrasse Tyson bluntly summarizes this scenario. He noted that since we are all moving with the Earth, if it suddenly stopped and you weren't literally seatbelted to the bedrock, you'd essentially roll over at 800 to 1,000 miles an hour due east. As he perfectly puts it, people would be flying out of windows and that would be just a bad day on Earth. The sheer momentum would violently throw literally all of human civilization into the air. Now, you might be looking at this map and thinking, hey, I'm safe if I just move to Antarctica or the high Arctic. And okay, sure, the rotational speed at the geographic poles is practically 0. You wouldn't experience those insane 1,000 mile per hour winds, but don't pack your bags for the South Pole just yet. While you might avoid the initial wind blast, the resulting global failure of the electrical grid, the instant disruption of global climate systems, and the total collapse of food and transport networks, yeah, that will still catch up to you. Nowhere is truly safe. But remember, our thought experiment states that the Earth starts spinning again after exactly 5 seconds. Welcome to the violent restart. The absolutely crucial point here is that the restart is not a clean, magical rewind button. The crust violently accelerates back to its original speed. But now it's accelerating into a world that has just been completely smashed, redirected, and mixed up. Displaced ocean water is still flowing in massive tsunamis. Debris is still flying everywhere. The restart just creates another violent mismatch of momentum, smashing the accelerating crust right back into all that displaced matter. It is a messy, apocalyptic conclusion. All right, so far we've treated this almost like a computer simulation. Let's move to our final, most accurate scenario, Scenario 3, real physics. Because you see, you can't just hit pause on a planet. Earth's rotation contains an incomprehensible amount of kinetic energy. The exact number is roughly 2 × 10 to the 29th joules. To try and put that into perspective, that is an amount of energy that dwarfs all human energy generation combined over our entire history. It's an astronomically huge number. And according to the strict laws of physics, energy cannot be destroyed. To stop the Earth in just 5 seconds, all that kinetic energy has to go somewhere. The sheer external torque required to break the planet's momentum would instantly convert that kinetic energy into heat and physical deformation. The crust wouldn't just stop like a brake disc on a car. The planet would quite literally melt, fracture, and completely dismantle itself from the inside out. And this brilliantly illustrates why we couldn't stop it ourselves, even if we all coordinated and tried. A pretty amazing study in the Journal of Physics Special Topics calculated what would happen if every single human on Earth ran in the opposite direction of the spin, or if every car drove westward. Because human mass is just so microscopic compared to the Earth, if we all ran, we'd only alter the day by 0.153 nanoseconds. If all cars drove, just 3.7 nanoseconds. To actually stop the Earth, we'd have to run way faster than the speed of light, which is, of course, physically impossible. Finally, let's step away from the 5-second rule for a moment and look at the permanent consequences, the long-term aftermath. If the Earth just stopped and never restarted, our entire map would completely change. Right now, Earth's spin creates a centrifugal force, making the planet bulge at the equator, pulling ocean water right along with it. Without that spin, gravity takes over entirely. The Earth becomes a perfect sphere, and the oceans would rapidly migrate toward the poles where gravity is strongest. This would flood the northern and southern hemispheres, completely revealing a dry, massive, continuous megacontinent wrapping all the way around the equator. Beyond just a new map, we'd be facing a completely alien environment. A single day and night would each last 6 months. One side of the planet would be scorched by the sun, while the other would be deeply frozen in darkness. Plus, without rotation, the liquid metal in our core might stop flowing, which collapses our magnetic field and lets in deadly cosmic radiation. And, fascinatingly, without the Earth's tidal acceleration pushing the moon away, the moon's orbit would actually start to slowly contract toward us. Ultimately, this explainer proves that we take our invisible, constant motion entirely for granted. That 1,000 mile-per-hour spin is literally the engine keeping our oceans in place, our temperatures moderate, and our atmosphere breathable. It's an incredibly delicate balance, which leaves me with one final thought experiment for you to ponder today. We've messed with momentum, but what if we tweaked a completely different fundamental force? What if gravity suddenly doubled for 1 minute? Let me know what you think would happen.